Good afternoon, everyone. Welcome to our session, Generative AI Architecture Patterns in Production for SMBs. I am Pranav Sharma, EMEA Lead SA for AWS SMB Business, and I am joined today by Jay Rao, who is Principal Solution Architect based here in the US, again supporting SMB Business. So agenda for our talk is, we will start with briefly discussing evolution of generative AI over last few years, just to set a stage quickly. Then we'll take a look at how customers are adopting generative AI. We see some common patterns as we see them all, and then we will be presenting them back to you and just trying to understand from you, like, is that what you see in your business as well? Then we will discuss 3 common architecture patterns that we have seen customers use as they have deployed generative AI architectures in production. And then gradually we'll move on to, as we move into 2025, how do we see these architectures evolve? And we'll particularly focus on the platform mindset. And then finally, we will close out with how, as AWS, we can help you, no matter where you are in your journey. You might have just started, might have already progressed quite a bit, or might already be a leader in your segment. We do believe that we have the skills, technology, and resources to help you in your generative AI journey. So let's get started. So the field of AI is not new, right? It has been around for 50 to almost 70 odd years. But then it all changed a couple of years back when November 2022, ChatGPT was launched. And then from that moment onwards, AI from being a technology which was just accessible to a handful of people became something with millions of people around the world were using to make themselves productive and then answering some of the queries that were most pressing to them. In 2023, we launched our own AWS Bedrock service to give customers access to large array of foundation models so they could build generative AI applications. So 2023 was the year of exploration and experimentation. We saw our customers actively engage with the technology to understand what it can do for their business and how it can transform their customer experiences. From 2023, as we moved on to 2024, the focus shifted just from trying things out to actually launching stuff in production to deliver some real business value. So the focus was on observability, focus was on security, and many other things like these for this year. And then gradually, as we move on to 2025 and beyond, now the focus is shifting more towards scale. How can we scale this faster? How can we increase the developer velocity? How can we reduce time to market? In general, how do we increase adoption more broadly of use cases within the organizations? So last few years, as we have been working closely with our customers, right, we have seen as SMB, like we have a wide array of thousands of businesses across the globe. Each of our customers are unique in what they offer. They have their own different industries, and they all have their own aspirations, which are different from Gen AI. So what is then common, right? With all these differences, we still see 3 commonalities between them as they approach generative AI. And this is what we are calling as the mindset. The first mindset that we are presenting to you is the AI pioneers. These are those organizations that not only believe in power of generative AI, but are investing heavily in building transformative use cases. These transformative use cases are end customer facing and then usually require backing all the way from their board, executives, to basically transform their industry. And we'll give you a few examples in a bit. The next set of customers, that the kind of mindset that they are taking is more of an adopter's mindset. So their focus is more like, as I gradually build skills in my organization, how can I, release a few use cases which are quick to market? How can I get a quick business value out of this as I gradually grow the knowledge in my organization? And finally, even though we would want to believe that everybody is building generative AI applications, but well, that is not true. There are quite a few customers out there who are playing this cautious game. They are closely observing this space, but yet are not developing anything just purely based on their business priorities. Some of them are in regulation. They're still trying to understand how governments around the world are taking up AI. Now, all these 3 mindsets or strategies are like, there is nothing better or worse. They are all good. And you can relate them almost back to, kind of how when we invest, we follow an investor philosophy. That is what this is. The pioneers is a more high risk, high reward game. Adopters is more of a in-between kind of an approach, and observers are playing this cautious game. So let me give you a few examples to solidify this further, right? And the key takeaway that I want to leave with you is this: which is the mindset is your organization taking? Is this even a conversation within your organization, right? That's what we want to kind of drive out of this. So the first AI pioneers use case that I want to present to you is a UK-based law firm, right? They are a law technology company. What they're trying to do is building a large language model focused just on legal domain, right? They're not using these out-of-box models, just trying to do a small fine-tuning and then using it. They're actually building it from scratch because legal domain is expected to be hugely disrupted. It is a research-intensive domain, a document-intensive domain, a text-intensive domain, and they are committed to transform this, right? And so they are investing to build a large language model focused just on legal domain. And their expectation is they'll be able to cut down the research time by 30% and increase revenue per employee. The second example that I want to present to you is a education technology company based in Europe. Now what they are building is an immersive precision learning platform. I know it's a bit of a mouthful, right? But then what does it even mean? What is immersive precision learning, right? Now, today's learning platform as we know them, right? Imagine if you want to take an AWS certification, some of the common learning platforms that we will use will offer you a text or a video-based course, which will be same for everyone, right? And all of us have our own different strengths and weaknesses across different topics that will be evaluated in the exam. Now, what this organization is doing is they have developed an AI coach, which will engage closely with each of the learner to understand their strengths and weaknesses vis-a-vis the expectation of a particular exam. And then it will deliver them tailored precision content to bridge that gap as quickly as possible. And then also have capabilities to constantly help them revise, remind, that sort of thing. And I'm sure you all would have experienced similar platforms like Khan Academy, even Duolingo has quite a few features like that. So again, this is one area, education sector, hugely disrupted by generative AI. And here is one example where we are seeing a customer do it. And then finally, we have this digital health insurance company, again based in Europe. What they're doing is super personalized, hyper personalized policy generation, dynamic policy customization, and other features which our traditional insurance companies are unable to do with the power of generative AI. Now, the commonality that you will see across these use cases, right, is they are at the heart of the business. They are not like some peripheral use case, right? They are at the heart of what the business do. So that's why they are kind of a pioneer use case. And then another key point that you would see is most of these capabilities do not exist today, right? So these are kind of leading the charge in defining these experiences, and that is why we are calling them as pioneers. Now let's take a quick look on the adopters use case, right? One of the most common out of the gates, I'm sure you all would have experienced this, is customer and employee experiences, right? Internal facing chatbots, customer facing chatbots, and we see wide adoption of these amidst the adopters community because it is relatively quick and easy to get business value out of these. The next one, super popular image and video editing use case, right? Particularly for e-commerce applications, those stock images, those models which, wearing different kind of clothes, different accessories, all that increasingly become super easy and popular with generative AI applications, to create those tailored images using generative AI. And then finally, for marketing, right, these personalization and recommendation. With generative AI, it has become very easy to have targeted email, very tailored to an individual user. Even the images generated can be very tailored to the user. So these three are sort of most common adopters use cases that we have seen. Now you can see one common pattern across these three as well, right? The first one being these are never the core and the heart of the business, right? These are more peripheral support system, and that is why we are classing them more as sort of adopters. Now, before we move on to kind of discuss three architecture patterns, what we are here to present today, right? I just wanted to give you a quick overview of AWS generative AI stack so that you can approach those three architectures which Jay will present with this sort of mindset, right? The first one at the bottom, we have this infrastructure layer. Through this infrastructure layer, you have access to accelerated computing instances and GPUs from NVIDIA, AWS custom silicon, lots of exciting announcements. I'm sure you've heard about them. So that is our infrastructure layer. Above that, we have tools to build generative AI. And here sits the Amazon Bedrock service, right? Through which you have access to loads of foundation model across different providers, many different capabilities that are being announced as well. And then finally, we have this third layer, which is the application layer, where Amazon Q sits, which makes it easiest and fastest to build generative AI applications. So with this, I would want to hand it over to Jay to take you through the 3 architecture patterns.
Thanks, Pranav. So as we keep that AWS Gen AI stack in mind, I'm going to present some of the common patterns and architecture use cases that we've seen in 2024. The first one I've seen is around employee productivity and knowledge management. It's prevalent across a number of industries, but an example use case would be a financial industry wants to use this use case for compliance and risk management processes. So imagine their compliance officer wants to use natural language and ask questions such as, what is the anti-money laundering regulation recently for EU? And then using the internal banking documents, the policies, the public regulation documents, the use case or the architecture will generate a comprehensive response, and with keeping their access pattern in mind. So a senior officer will be able to get information from internal banking strategy, whereas a junior employee might just get a generic response because of their access. At the core of that use case for knowledge management and employee productivity, a common way to build that is using Amazon Q Business. Amazon Q Business is a generative AI-powered assistant, which is very simple and easy to adopt and build on. It does a number of things on your behalf on the back end. So you don't need to worry about the model selection. You don't need to worry about building any pipeline or vector database or embeddings. It does all of those things on your behalf, which allows you to do a quicker adoption as well as the adoption from your non-tech teams such as sales or marketing or legal. It also provides a number of out-of-box connectors. So if your data resides in, let's say, a different data repositories or sources, you can use Q Business to connect to those and then bring it all in for the knowledge management use cases. And lastly, it also supports and provides a complex authentication and authorization. So you don't have to build that. You can use that capability that Q Business provides out of the box so that, again, like I said, you can have a quicker adoption and a quicker ROI. Diving a bit deeper into how Q Business does it in terms of the architecture, let's start at the left. So the data is ingested from all these data sources. I'm just showing some few example data sources, but as I said, there are a number of those available. Using this connector and the data, the documents, and the permission information is ingested into the queue. And the queue users on the right-hand side will be authenticated. And using this authentication token, they will be making the APIs to the queue to interact with that knowledge base that you set up. Again, like I said, a number of things that the queue does it is on your behalf in the backend. So these users can interact through various channels. You can see it's a web experience, so you can have a dedicated web experience where your users can go and interact with the data that you pull from the data sources. Or you can have this embedded. We recently launched capability where you can have this Q Business embedded into your existing application, so users don't have to go to a different portal or a different application to use this. Or you can have this integrated into channels such as Slack or Teams, so your users can directly tag a bot and then have a conversation or get the information that they are looking for. Lastly, Q Business also provides logs and metrics using CloudWatch and CloudTrail, which is very useful when you're building the application, especially from the administrator point of view, when you want to have that visibility on how application is doing, how users are utilizing that application. Some of the things that we saw that in the adoption of Q Business for that knowledge management and employee productivity use case, the consideration that I wanted to highlight is the flexible authentication that Q Business provides. So as I mentioned, Q Business does take care of the authentication and authorization where you can use your current IDP or identity provider. So you don't have to create a new IDP or a new system to manage those users and permissions. Although you can also build something on AWS Identity Center if you don't have an identity provider where you're managing that set of users. So there's a flexibility that comes inherently out of the box that I wanted to keep in mind. Second is there are a few subscription tiers in Q Business. So you can choose, based on the user and their roles and their needs, you can choose which subscription tier is appropriate for which sort of or which class of users. So there's Pro and Light subscription tier. Light subscription tier allows users to interact with this knowledge, enterprise knowledge bases and get the response or insights with citation. Pro tier allows more than that. Pro tiers allows access to Q apps as well as ability to upload documents in the chat so that they can have an insight or interaction with the information that is uploaded just in real-time dynamic document interaction. As well as it allows a number of other capabilities as well, such as browser plugins and direct query the LLM. So you can also use, you can query the LLM directly if you want to use the LLM's inherent knowledge. Observability in any application is key, but it's getting more and more prioritized in generative AI as the use cases and the industry matures. As I mentioned, Q Business has a number of different metrics and logs that it exports in Amazon CloudWatch as well as CloudTrail that you can use them out of the box to understand how your applications are being used, which plugins are getting invoked, which Q apps are being invoked and how many times, so that you can have, as an administrator, you can have that visibility and understand if you need to make any changes, if you need to make more of those abilities or features available. Q Business also recently launched something called Analytics Dashboard, which is like a comprehensive view where you can have all these metrics and the trends. I think the trends is the key thing. You want to understand how your users are utilizing this Q Business and app application. And this analytics dashboard that Q Business provides out of the box becomes very critical part of it. Multimodal support is also something that's becoming a key. So if you have documents, right, often you have documents where you have tables, you have charts, you have graphs, you have images embedded into it. And previously, it was very hard to get the insights from those elements within those documents. But Q Business recently launched capabilities where it can index and understand the visual element that are integrated by default out of the box, so that you don't have to do any additional stuff or pre-processing to get those insights from those visual elements. So when your user is asking the query and if the answer lies in a table or in a graph or an image, it will understand it and it will also bring that graph back in the response as part of the citation. This is all out of the box, right? So this is becoming, again, like I said, multimodal is becoming the next big thing in any of the GenAI use case, and Q Business provides this out of the box. Lastly, evaluation is also very key. Any application you want to build, especially GenAI application, you want to have an evaluations as a part of the workflow. You can use the evaluation frameworks such as RAGAS for evaluation, as well as you can also have a human in the loop for any use cases where you want to have a human reviewing those evaluation matrix as well. Use case that I want to highlight, there are a number of customers using Q Business for employee productivity and knowledge management use case, but SmartSheet, which is a work management and collaboration SaaS software, they've had a difficulty fetching the right information, which was spread across multiple different documents. And it was time consuming for the users to fetch that information across public documentation, training courses, as well as internal channels. What they did was, they using Q Business, they consolidated all of this knowledge into this one application and integrated this into their Slack channel so that the users from the Slack channel can just directly invoke and identify the right information that they're needing at the time, saving them hundreds of hours as a productivity by using this no-code implementation. Another use case that we've seen commonly in 2024 is intelligent document processing. Again, like I said, this is also another use case where we have seen across a number of different industries which deals in documents. For example, a consulting firm in the US is using this use case for their payment intelligence solutions to pay their claims accurately. And implementing this intelligent document processing using these Gen AI-powered solutions, they were able to have 5% savings because they were processing those claims inaccurately before. So there's 5% savings right out of the box by using this implementation. And not only that, the solution that they implemented processed 30 million documents in 6 weeks at a 90% accuracy, versus the previous solution, which was non-Gen AI based, was only able to process 10,000 documents in the same period. So you can see the scale at which it was able to unlock for that customer to process and onboard new customers, and in turn, increasing their revenue as well as the efficiency, as I mentioned. And they're planning to really extend this solution to a number of different industries that they work with. And at the heart of it, like a core of that intelligent document processing is Amazon Bedrock. Amazon Bedrock powers a number of different use cases, but we've seen for intelligent document processing, it has been the key service or key use case. Amazon Bedrock is our generative AI service, which allows you to build and scale this application, providing a large number of model choices across proprietary model, domain-specific models, as well as different types of modality like text, video, images, as well as the embedding models, and we recently launched some of the re-ranking models, and I'll speak to more about it. We also, Amazon Business also supports model customization. So there are use cases where you do need to have model customized or fine-tuned for your use case. It supports managed fine-tuning, a pre-train, continued pre-training, as well as we recently launched something called model distillation, where you are taking a large model, which is often called a teacher model, and you are condensing specifically fine-tuning for your use case and making a smaller student model out of it. So you're gaining efficiency, and since the model is smaller, it's cheaper as well as faster. So the distillation feature is also available within Bedrock that supports. Bedrock obviously supports the managed RAG evaluation, so through managed RAG as well, like through knowledge bases, as well as it supports model and RAG evaluation as well. Integrated as part of it, we recently launched capabilities where you can have a programmatic evaluation or LLM as a judge, which is another concept which is getting very popular, as well as RAG evaluation as well that is integrated or inherently supported in Bedrock out of the box. Bedrock also supports prompt management as well. So not only you can manage and create prompts and manage its versions, but Bedrock also has capability to optimize this prompt as well for the model that you're using. So that's also a capability that's inherently baked into the Bedrock. A few other things around agents also is something that you're asking the models to do the task on your behalf, right? Multi-step task. And we actually launched a few features around agents this week on Amazon Bedrock. All this using the security, privacy, and the governance that you're used to getting from AWS. So like I said, there are many patterns in which Amazon Bedrock has been used, but the most common pattern that we see, especially for the intelligent document processing, is the travel augmented generation. You might be familiar with that. And just a quick review of it, there are two flows in this RAG architecture. There is a document data flow where you are ingesting the document from different data sources. You might be chunking them. You might be splitting them. And using embedding models, you are converting them into the vector representation, storing into some sort of vector database. And when the user asks the query, you are converting that query into a vector, and then using, and the vector database basically does the semantic similarity search to find the right context and generate, give it to the large language model to generate a final response. Again, like I said, this pattern has matured quite a bit. And the particular portion that we've seen in 2024 that getting more mature is the query data flow. There are a number of different techniques that I'm highlighting in this advanced RAG architecture that will go on one by one. So instead of always sending the query directly to the large language model, the caching concept took really big, got high adoption in 2024. And caching is not new. You're all familiar with caching in regards to database. The similar concept applies here, where you're, instead of sending every query to the large language model, for all semantically similar questions, you are fetching the answers in the cache first, and if you find the response, you can just send that response back to the user, and you don't hit the LLM, you don't incur the cost, as well as there's a latency benefit as well, because you're going to retrieve that information quite faster. So that's, again, there are a few types of caching. We also announced this morning with Bedrock prompt caching, where you're caching the prompt itself, where you're not resending the prompts, gaining efficiency in the number of tokens that you send. So that's also you can consider as part of the whole caching criteria. Let's say if your query is not, do not have a response cached, the next advanced technique that we have seen more common in this advanced RAG architecture is around the query translation or query expansion, basically. Or if you have a large query, large complex query, you can use this LLM to split this query down into multiple small queries. There are a few benefits of that. One, you might get a better response because it's no longer that complex, one large task, as well as there are some tasks that you can parallelize so that you can even get the latency benefit as well, because those tasks are happening parallel, those calculations are happening parallel. So that's one way of the query translation, query expansion. Another thing that you can think of it in the query translation bucket is typically when users ask the queries, they don't always formulate the questions that is most optimal way to ask that question, right? Like there are better ways to ask that question. And the way that you can reformulate that question or rewrite that question is using some of the large language model. And Bedrock provides this ability out of the box as well, where you can have another large language model rewrite that question so that it's more appropriate and then it will better perform to fetch whatever the right content that you're looking for. So once that optimized query is there, another technique that you can potentially, and remember, these are all stages that you can optionally add or remove depending on your needs and the criteria that you have. So once this optimized query is there, another technique that is very popular is query routing. Whether you are routing the queries to different data sources or whether you are routing the query to different models. As we announced this morning, you can have a simpler query route to a smaller model or a more complex query route to a larger model, again, gaining some cost and latency efficiency as well. Once you have this context retrieved from the knowledge base or database that you are fetching that content from, you can also introduce a stage where it's you can introduce a stage called re-ranking. So there are situations where when you're retrieving the context, they may not always be in the right relevant order. And especially when if you have implemented RAG, you might be fetching 10 results, but you might not be providing the 10 results to the large language model. You might be capping at top 3 results, top 5 results. And if your relevant context is not in the right order, you might be missing out on getting a right or accurate answer, which is where re-ranking comes into the picture. That you're re-ranking all the retrieved results based on the relevancy. And those re-ranked results then will be passed on to the large language model. So Bedrock supports a re-ranking API, re-ranking models out of the box as well. And this is another pattern that we have seen this year where more advanced RAG implementation often involve a re-ranking stage as well. You can also optionally involve a couple of stages that I mentioned here, especially the search one. So if you do not find a relevant context from the RAG, you can also invoke, think of it as a dynamic API where you're fetching something from the outside using the search API and fetching that results and providing that results along with the retrieved context to the large language model so that the response generated response is more accurate and relevant. This is, like I said, more advanced pattern, and we have tried to add all the techniques that we have seen into this architecture. As I mentioned, you can pick and choose or remove some of this technique depending on your needs and use case. I want to talk about one of the customers who have used this pattern is Dandy AI. They are an e-learning platform. They provide this personalized tutor to students who can use their own notes to generate this personalized learning plan similar to the use case that Pranav talked about. They actually have 40,000 students across hundreds of country and multiple different language. And their goal was to reduce the time between the user uploading their notes to the time when the users are essentially getting, whether it's a flashcard that they're creating, personalized flashcard, or personalized, the test that they want to create just to learn certain topics or the concept. They wanted to condense that time. And their previous solution was suffering from high latency. So using Bedrock, and some of this better capabilities such as knowledge base and some of the features that I mentioned, they were able to build a scalable serverless architecture and they were able to achieve a 40% sort of faster, 40% better latency so that the user or the students essentially are getting the answer to the response faster. The third use case that we have seen is more around the image modality, right? Image generation and image editing, especially on the teams, marketing, or product, or retail, or advertising. These are the teams typically we have seen this use case more common, where you're using these large language models or foundation models essentially to create ad variations or product variations. You can easily and quickly do those so that there is a benefit in terms of the reduction or faster time to market as well as the cost, because some of those things, the photographic cost and other things add up. So this way, they are not only going to the market faster, they are also reducing the cost as well. And at the heart of it, some of these use cases we've seen, they're all powered by, a lot of them are powered by AWS design silicon or purpose-built accelerator. You've seen probably in the keynote some of these accelerators such as Inferentia, Trainium, or Inferentia 2. Using this accelerator, customers have trained, tuned, and deployed this large language model, which are cost-effective and high-performant. As a matter of fact, Amazon.com uses this purpose-built accelerator for their own generative AI assistant, shopping assistant that they call Rufus, integrated into the Amazon.com. They have ingested hundreds and thousands of product catalogs, user reviews, community forum, all those things, so that assistant is helping the users make the right choice, do the comparisons, have this interaction. In the last Prime Day, they actually used 80,000 of Trainium and Inferentia chips for the Prime Day across multiple different regions, and they were able to produce 3 million tokens a minute kind of throughput at a 1 second latency for the P99 for the first response. All of this at a 4.5 times cheaper versus the other solution that they evaluated. So not only these are, like I said, cost effective, but they're also highly performant accelerator. An architecture that I want to talk about in terms of the image generation and the modification. So imagine like a user has a mobile app or web app where they are using this, let's say backed by ECS or some sort of compute platform. They would get a signed URL, and then they will upload the image to S3. And S3 has multiple tiers, as you'll know. One tier that I want to highlight is S3 Express One Zone, which is a high-performance storage tier specifically useful for this kind of use cases where you need a high throughput, low latency kind of a storage tier at a lower cost as well. So when the users upload those images on in the bucket, a serverless workflow triggers using Lambda, SNS, and SQS. And essentially, those models are hosted on EC2, powered by those silicons, AWS silicons I was talking about, with auto scaling baked in as well. Those models either generate those images or modify those images depending on what the use case is. And then another, through SQS and Lambda, another workflow kicks off, and then reverting back to the user using something like AppSync. And you can store your state in DynamoDB. You can even choose to store the result in the S3 bucket as well if you want to have that users access those images later on as well. So you can add that piece. One of the customers, actually, the same customer utilized the previous architecture is Lyrebird Studio. They are a global developer and publisher of a Gen AI-powered application, image and video editing application. They actually provide over 50 different mobile applications. And they have over 2 billion downloads, so they're very popular. Their goal was to increase the revenue per app by reducing the inference time as well as deploying more and more this image and video models, again, in a multi-region setup. The scarcity of A100 GPU as well as the high cost and the latency, that became a bottleneck for them to achieve that particular business outcome. So what they did was they worked with AWS team. They are successfully evaluated and implemented on AWS Inferentia and Trainium chips. And eventually they got to that result with a lower cost, 31% lower cost, with a 19% improvement in the inference latency as well as the high throughput. So as you can see, using those purpose-built accelerator, Lyrebird Studio achieved a lot of those results, business outcomes that they were looking. So now I want to hand it back over to Pranav to talk about how we think these patterns, these use cases will evolve in 25 and beyond.
Thank you, Jay. So now that we have covered what we saw in 2024, we are almost at the end of 2024. So what are we looking for next year and years to come? How are these architectures going to evolve, right? And that's where we want to talk about the platform mindset, right? I'm sure many of you would be aware of this, but then that's what we want to discuss, that what it means to apply platform mindset to generative AI, right? So as we move from early applications to really scaling applications in production, some of the common questions pop up, right? It's like, how do I lower my cost? How can I apply organization-wide patterns, right? How can I increase developer velocity? Or for example, how can I share best practices? I'm sure you all have heard these questions discussed in organizations and many solutions I'm sure you have created already for this. But one thing that we have seen often comes up is applying the platform mindset, right? This is not new. This platform mindset has been applied earlier in, say, context of microservices, in context of data platforms, right? So what is the platform mindset? Essentially, the idea is very simple. Take a look at common applications, number of them that you want to build as a whole, and then see what are the common components, right, that those all applications need. And then rather than every application team building those components, they have a platform team dedicated which will then build those components at a super high level of quality and then expose them to different application teams, either in a shared deployed manner or shared templates of infrastructure which they can instantiate and then use them. So that is what platform mindset is, and it is being applied already at scale for microservices, data platforms, and many other use cases. So now, in next few minutes, we are going to look at what it means to apply this in context of generative AI. So together, we are going to build a generative AI application platform, right? So what would be the building blocks of a generative AI application platforms, right? Let's think about that a bit. So we have these data sources within our organization. Some are internal to organization, some are external as well. We have external partners. So what is the first component, right? At the heart of any generative AI application is data. Access to data is critical. So the first building block we need in a generative AI application platform is data for AI. Now what does this building block do? It provides two key components, right? The first one is very simple. Documented data pipelines that will connect to different data sources within the organization or outside of the organization. Transform the data. What sort of transformation? This is almost like chunking the documents, generating embeddings of them. We discussed about multimodal embeddings, stuff like that, just making that data ready for AI and then pushing it into knowledge bases. And knowledge bases are these purpose-built databases that have capability to handle vector storage, access vector, search vector, that sort of thing. So this is the first building block of a generative AI application platform. Now, what would be a second building block, right? Generative AI applications, after data, the next thing they need is access to foundation models, right? And we want to ensure the access to foundation model is secure and all that good stuff, right? And that is our second building block. That is the AI core, right? And alone foundation model are not enough. We need capability to create agents, evaluate them, many other things, build guardrails. And all of these together form the AI core. So that is our second building block. The third building block is application backends, right? So because when we are creating the platform, we want to ensure that multiple applications are built on top of this platform, right? So for example, in context of a bank, right? There will be one group which might be building a payments application. Then there will be another group which might be wanting to build a mortgage application. And they all will want to have some kind of business logic which is personal to that application. And so for that, we need this application backend component where applications will build their own custom business logic, will have different patterns of connectivity that their clients will need, and then also have some kind of storage interaction store that we are calling here, wherein as clients talk to the backend, the storage can be done. So what's the next component, right? As we are building these applications, we need to manage them, operate them. And to manage and operate, we need capability for observability, logs, metrics, all that good stuff, right? Obviously, we want to authenticate, authorize, so then we have a security component within the operations block. And along with that, AI operations pipeline, which provide the capability to move from one environment like test, dev, prod, the movement of application, and then finally, for every application, we need some kind of business metrics and reporting, right? Essentially, the application is put live for a business purpose. Is it meeting its business objective? Are the user liking it, not liking it? All that stuff is accomplished using the business metrics and reporting. And the last block that we need in the platform, the fifth block, that is the platform control plane. The core role of platform control plane is to help onboard these many applications. So for example, in banking context, the payment application needs to be onboarded. The mortgage application needs to be onboarded. So this is where is provided through what we call as platform governance component that you see on the top. Then obviously we have to have a developer assistant, right? We want to make life easy for platform administrator. So and also the platform developer. So that is provided through platform assistant. Along with that, we have components like internal developer portal and also environment orchestration and management pipelines. So now let's go deep into each component one by one and see what capabilities these 5 components provide to build this platform and what are the AWS services that we can use to build them on AWS. So let's start with data for AI. So we have these many data sources. These could be code repositories. These could be enterprise content management stores. These could be many other external data sources as well. The capabilities that the data pipeline needs to provide starts with ability to connect to multiple different data stores. So it needs a good portfolio of connectors to multiple data sources. Then as we extract the data, we might need capability like PII removal. Then, because we will be ingesting many different documents, we need some kind of chunking capability so that we can cut down the documents into smaller chunks, generate multimodal embeddings from it, add master data so that the documents become easily searchable, and finally load this data into knowledge bases. And within AWS, we provide multiple options that you can choose for knowledge bases based on the requirements of your application. Now, how do you build such a data pipeline on AWS? What are the services that you could use? So you could start with AWS Glue. AWS Glue has awesome connectors for many, many different data sources, so you don't have to build by yourself, and you can just pick and choose and start connecting to the sources and also loading to the knowledge bases that you want to load the data into. The next service that I would want to highlight is step functions, because essentially these are workflows which we want to orchestrate, and AWS step function is a serverless service which makes it super easy to build orchestration of such workflows. Amazon Textract will help you because documents might have images and you might want to extract data from those images. So Amazon Textract's OCR capability will help you build that. And then Amazon Bedrock is required to generate multimodal embeddings for generative AI applications. And then AWS Lambda provides a general purpose compute layer. And then finally, Amazon Comprehend, which helps you remove PII in the data that you might have, right? So this covers the data for AI. This is our component number 1. Now let's move on to component number 2, the AI core. Now this is at the heart of this particular platform, right? So it has quite a few components. I'll try to go one by one. Let's see. The first one is AI Gateway. Now AI Gateway provides secure access to foundation models. It also provides a unified API because foundation models, as you know, are super fast evolving. The foundation models that are leader today may not be leader tomorrow. Because of this, you don't want your applications to get impacted if you want to switch foundation models because just a new state-of-the-art model came. So this foundation AI gateway provides that unified API layer so that your applications interface to the gateway, that construct remains the same, but behind the scene, API gateway can have different adapters which can change, and then it can talk to many different foundation models. You also want to build in some kind of cost and usage tracking, right? Because within an organization, that has multiple different applications talking to the same AI gateway. You might want to do cost attribution, that which application is consuming what sort of resources, and that is something you want to build in an AI gateway. And finally, like I said here, it could be dedicated or it could also be shared across applications. And this could very easily be built using API Gateway, Lambda, DynamoDB. All three of them are serverless, so you don't have to worry about scaling them, and they scale seamlessly at the level you want them to be. The next core component obviously is the foundation model themselves, right? And you want foundation models to have like wide choices. You may want them to be self-hosted, maybe managed through different services. Again, you may want these foundation models either to be shared between applications, or you might also want them dedicated, again, based on the needs of the application. So the choices that you have for this layer is Amazon SageMaker, which provides the Jumpstart offering through which you can have access to a wide array of foundation model. The Amazon Bedrock service, through which, again, you have multiple choices. And then finally, even Amazon Q as well. So here, if you see, by applying this thought process, within this one block, you are able to bring together all the three layers of generative AI stack that we saw earlier in the presentation. Now, next three capabilities, the prompt management, agents, and also guardrails, right? These are very fast evolving space, and they have capabilities which are required as you build generative AI applications, and then there are same set of services that you could use to build them. Now, Amazon Bedrock provides all these capabilities out of box, right? So if you don't want to build something custom, just want to quickly get started and use something, Amazon Bedrock is the choice for all these three capabilities: prompt management, agents, and guardrails. But if you have a need to build something custom because of your use cases, you can again use API Gateway, Lambda, DynamoDB combination to very easily build them, manage them, and scale them. And the last capability in this block, what we need is evaluations, right? As you build many different use cases, for example, classification, Q&A, summarization, you need different type of evaluation solutions, right? And you need access to open source data sets, because you might not always have your own internal databases for all these different use cases. So you need a way to have quick and easy and secure access to open source data sets. And then you also need some kind of popular metric support just to evaluate against these tasks. So the services that can help you build this is Amazon S3 for storing all these open source data sets or some of your own internal data set as well, and then orchestration through step functions, and then AWS Batch provides the core compute layer to run this long running task. And again, if you want to use something out of box, Amazon Bedrock already provides it, so you can very easily use it in the most easy and simple way. Now let's move on to the component number 3. This is the most simple component, the application backend. It provides a gateway through which different clients can talk to your generative AI application. It provides general purpose compute capability, so you can write business logic. And then you need some kind of interaction storage as applications talk to the backend. Now these can be built using some of these services. One of the core points that I want to add here is you want to provide multiple access choices, because there will be some clients which would want a request and response. Immediately they send the request, they want a response back. So the synchronous pattern. There would be some which might want to use a bit of asynchronous, so they might want to fire and forget. And with that, you can introduce services like SQS into the mix, which help you build those asynchronous patterns. And finally, you also want to support the batch pattern, right? Which can be supported with AWS step function, AWS batch as well. The next block is application operations. The first one capability that we need in app operations block is observability. For that, essentially allowing applications to do logs, traces, metrics. This capability can be deployed in the applications account or could also be shared, and then it provides capability for both monitoring infrastructure and applications as well. And then it provides capability like alerting. Now there are a lot of choices to build observability on AWS, but here we are providing some most simple choices: Amazon CloudWatch, X-Ray, and SNS for notifications. You can build a very quick and simple observability stack very, very fast. The next capability obviously is application security. You want to secure your applications by providing authentication and authorization capabilities. Your applications want to connect to different data sources, so they may want to store credentials, so you need secrets management. You want to provide encryption at rest and in transit, and also you want to prevent prompt injection attacks, right? All these capabilities can be built using AWS Security Service. The KMS provides you encryption services. AWS Secrets Manager can be used to safely secure all the secrets as you connect to many different systems. AWS WAF provides you capability to prevent prompt injection attacks, and AWS Cognito and Amazon Verified Permissions together provide you capability to do authentication and authorization. Now the AI operations pipeline. So these are the pipelines that help your application move from development, test to production, right? You need capability to do this propagation. These accounts are usually different. You would not be using the same AWS account for test, dev, and prod. You also might want some kind of human in the loop capability and also want to deploy applications to multiple accounts. These capabilities can be built through AWS code services. You can choose code repository of your choice that you might be already using, but then you can use code pipeline for orchestration, AWS code build for application code, and then CloudFormation for infrastructure code automation. And finally, you need a business metrics and reporting capability. As I discussed, you want to take users' feedback. Are they liking your application? Are they disliking your application? And you want to measure the impact that your application is having. So for example, if you have launched a customer-facing chatbot, is it really able to reduce the agent handling time in your contact center or not? So these kind of metrics you want to build. And this can be built with this component. The services that are most common being used here is Kinesis to stream the logs, the interaction logs that are happening between the clients and the backend services, and then S3 for storage, and then Amazon QuickSight to easily visualize the interactions that are happening. That concludes the application operations platform. And finally, let's come to the control plane platform control plane component. The first key block is the platform governance. This is nothing but providing SaaS-like capability to your platform because you are going to onboard multiple tenants. So for example, in banking context, this is like payments application, mortgage application, so these are different tenants. Now each tenant also will have multiple users, right? So a payments team might have 10 different developers, so those are users. So you need a user management capability also, and you need some kind of platform UI. These capabilities can be provided by, the UI can be provided by Amazon S3 and CloudFront, a very simple static UI which can act as the UI for the platform. And then between API Gateway, Lambda and DynamoDB, you can do the backend to provide SaaS-like features, and finally Cognito for authentication. You obviously want some kind of platform assistant capability to help your platform engineers and developers, and you want to do it in a way so that license management is simple and easy. That can be done through Amazon Q Developer. Now, I'm sure you all would be familiar with this concept of internal developer portal. It is quite a thing in sort of microservices world, and this is often required to improve the developer experience. It provides a single pane of glass for your developers as they do their day-to-day job of building and deploying and running code. This can be built using AWS Service Catalog, through which infrastructure templates can be shared across many teams, and then also Backstage, which I'm sure you guys are aware about. It's a super popular open source solution which can be built and run on AWS, and it can act as an internal developer portal, a front door for your generative AI applications. You also need some kind of platform operations, right? So imagine when an application team comes and asks you, hey, I want infrastructure for such and such application, you need to have this orchestration capability which will go and provision AWS accounts, required infrastructure for those applications requirements, and that is provided by this platform operations block. The capabilities or the services that can achieve these capabilities is code repository, which you might already be using, code pipeline for orchestration, code build for application, and then CloudFormation for the infrastructure automation. And finally, platform security. You might need some kind of SEIM solution. You also want to monitor the API access log as to how people are accessing your platform, and these could be provided through CloudTrail and Security Hub. I know I ran a bit fast on these, but we had quite a few 5 different components to cover across with many different capabilities. I hope this does give you a sense of that all of this can be built on AWS, and we do have some recommendation here as to what are the services that you could use. Finally, one last point I want to cover, that as you build this platform, what sort of account structure will it look like? You might already be using a multi-account structure with AWS Landing Zone, and this you can think of as just an overlay layer on top of Landing Zone that you might want to build. So one dedicated account for the platform control plane that you see within the infrastructure block, right? That is for the platform control plane. The shared services, imagine you have this AI gateway which is shared by multiple teams. So such resources you might want to put within the shared services account. And then you have accounts for each of the team, which are like dev, test, prod, and you can do multiple instances of them based on the number of tenants you have in the platform. So this concludes, a super fast tour of how to build a generative AI application platform on AWS. Now let's move on to how, as AWS, we can help you as you go in your in your generative AI journey. You might be getting started. If you are in that phase, we can help you with a one-day discovery workshop where our teams, free of charge, can come work with you and help you evaluate different use cases that you have and essentially help you prioritize based on our experience working with other customers. Once you have made a choice of the kind of use cases that you want to build, we offer you a design workshop, gain insights workshop, where we come and look at your data, spend 4 hours with your teams, and then understand, looking at that data, how that can be used to help you build generative AI applications. Again, this is offered free of charge. Within the experimentation phase, then we offer quite a few things. If you are doing a point of view, our demo squad, which is a 1-week offering where our teams partner with your teams and we build a super fast use case to prove the business value of the use case for your business. And then we also offer lots of enablement options through immersion days, etc., to help you, dive deep into a particular service or a particular architecture that might be of interest for you. And then there is also an MVP support, wherein through this experience-based accelerator over multiple days, our teams sit next to your team and together we work to build something and launch in your production. Again, this is the free of charge offering for you. So as you can see, there are quite a few options to help you within, across your journey. And if you are at the stage where you're really scaling, so then with AWS professional services and our partner ecosystem, we can help you, really scale your applications in production. With that, we conclude this session. Thank you so much for taking time for us. These are our, LinkedIn profile QR codes. We would love to, get your feedback. So please connect with us. And also do not forget to provide session feedback. Thank you so much.